In this lesson, we will create a server-side Node.js application using TypeScript, laying the foundations of our backend. Let's get started. In the future, we'll have a monorepo, but for now, we'll simply create another folder for the backend in our project. Let's open a new terminal window. We can create a folder like this, or, like cool programmers, write mk1 backend in the console. Folder created, now we can navigate into it, creating the backend. We've navigated into it, but of course, it's empty at the moment. So, this will be a Node.js application, which means we need a package.json file, which we can also create via the terminal. It's not strictly necessary, but still. Use the command touch package.json, and let's fill it in now. So, what's important here? The package name, this will be the backend. Then we'll indicate that it's private. This doesn't affect much, but it prevents it from being published to the npm registry. Actually, it's not very important. Then we'll set its version. Let's do it like we did with the web app. There we also have 3 zeros. It'll be the same. All right, and this is actually enough for minimal configuration. Now let's install the necessary packages. What do we need at this stage? Of course, TypeScript itself. Let's install it. And TypeScript is a dev dependency, so we add it with a flag. Like this, TypeScript. TypeScript installed. Great. So we have added node modules. Apparently, they are green. This means they want to enter our Git repository. We don't like this, so we'll also create a gitignore file. Now, not like cool programmers, but like ordinary ones. Gitignore. So, as a MacBook owner, I'll add a file called dev dependencies here, because Mac sometimes tries to create it. It's completely unnecessary for us. It's just garbage. So, I want to add node modules here. And I'll also add the dist folder immediately. Dist will be the folder where our backend will be built. Added. Node modules turned gray. Excellent. What? Now let's add our code. We'll store our code in the src folder, and we'll name the main file index.ts. For now, let's have our application just say hello to us. Console.log. Let's just have it say hello. Okay. Saved. So, as we can see, Prettier here doesn't work quite the way we want it to. Therefore, we can move it to a higher level, and it should continue to work. Let's move it and reformat again. You see, the rule has already been applied. Great. Good. Next, we need to run this code somehow. Let's install a package called tsnode, also tmodules, because in production, we will launch the saved project, which will already be in JavaScript. But for now, let's just run it through tsnode. Well, darn. Okay. And how do we call this tsnode now? You can add the pnpm exit command. This means executing the command based on the package that contains pnpm inside it. Because if we take just tsnode without a global installation, it might tell us that tsnode is not found. Thus, we indicated to pnpm to take tsnode, specifically from our node areas. tsnode rc index.ts. Here we got the message hello. In practice, our process, well, it wrote hello and ended the process. In reality, a regular backend process never ends. We release it, it's always running. because it's going to handle some requests from the front end and needs to be always attentive. Therefore, we need to install some tool that will allow us to automatically restart this process upon code changes so it applies. Okay, let's do this. For this, there's a package called tsnode-dev. Alternatively, you might have heard of it. You can use nodeman. Nodeman restarts the specified process whenever the specified files change, but it works slower than tsnode-dev. tsnode-dev works faster, and we will use it instead. T says node-dev. Let's install it, and we probably won't use tsnode directly. We'll always use tsnode-dev because it's more convenient in development, while in production, the regular node process runs anyway. Well, we've added tsnode-dev. Let's add a script that will run our development process. So, similar to how we did it in our web application, we'll do it here. Scripts. The first script is dev, and the command is as follows. So, tsnode-dev.src we index .ts. Okay, and we ask it to restart. For this, we specify flag rs. Okay, let's check how it works. Call the script in pnpm with the script name. All the same. Well, basically, that's what we were aiming for. Let's now try to build our application. How to build it? To build it, we need to create a command that will build, and it will call tsc, the TypeScript compiler, which was installed as part of the TypeScript package. But to build a project with TypeScript, we need a tsconfig file, which determines what rules to use to convert TypeScript into JavaScript code. Let's create it. It's config.json. It must be in JSON format, and there's nothing you can do about it at the moment. Well, no big deal. Okay, what should its contents be? Now I'm going to scare you. Look. This is the official documentation for tsconfig, and it's about this size. Here, you can sit down, read everything, understand it, and consciously write your own tsconfig. But in practice, I don't recommend doing it quite that way. Just take the one I'm suggesting to you. Here it is, and use it. Then, at some point, you'll encounter a scary error. At the most unexpected moment. It will be completely convoluted. You'll Google it and find an answer like, just add this parameter to your tsconfig, and everything will be fine. And the reasons are explained. You add this flag, then when you create another project, you'll pull the updated tsconfig. So, the main task of tsconfig is to make it work so that your application runs during development and builds correctly. In practice, you'll need to change something in the include field, where the files that need to be compiled are defined. Well, and also some other settings. And in this course, we'll return to this tsconfig a couple more times. But for now, just use it. The main points are that the build output should go into the dist folder, and we're using common JS modules. I don't want to delve into the history of modules. Just a warning. Don't use ESM in a module when developing a backend application, because you'll suffer later. And with JST and with the build, you don't need that. I'll leave a video description. You can watch a comparison of these modules. But in practice, this config will just work. It's also known that our resulting JavaScript code builds according to this JavaScript specification. So, we've created a tsconfig file. Now let's try to build our application. All right? How do we build? We build using the command build. pnpm build. We're getting a warning. It says that the console was not found, and we can see it here as well. Why is this? This is because you need to set types for node.js. Let's add them as dev dependencies too. pnpm id types node. All right, we see the error hasn't immediately disappeared. This happens. It might occur further on as well. If something's wrong with your code editor and it's unresponsive, there's the command palette command. Do we remember what to call it? View command palette. It's best to remember the hotkey, of course. Here's what you can do. Reload window, and then you will restart the whole window. But at the same time, your terminal windows will remain as they are. The only thing is, everything will refresh. You can refresh just the TypeScript server. TypeScript. Restart TS server. There's also this command. You can install it separately. Also, to have TypeScript support, you need the tscode extension. Okay? I'll leave a link in the lesson description to that TypeScript extension. Well, here's JavaScript TypeScript nightly. All right, type installed. Now everything should be built. Okay, it's built. A dist folder appeared, and as we can see, it's just index.js and also a map that connects the existing index.js with our TypeScript code, so we can conveniently debug this map when some errors arise in production. You can take a look at it. It's like this, which is basically quite expected. Good. We've built it. Now let's try to run the build project. How is this done? Well, there's a build command. We need the start command. All right. Well, yes, I agree with Copilot. That's what we need. Let's run the application and press start. As we can see, a regular JS file was already running. That's good too. All right. Another important thing. When we build the application, we should completely delete the build folder, because later some other files may appear or be removed, and they are not automatically deleted from the dist folder. Let's install a package called rimraf for that. This is a universal package that will work on Windows, Linux, and OS X. It simply allows us to delete what we ask it to delete. So, let's add this command to our build script. Rimraf, what to delete. And these two ampersands mean that after the successful execution of this command, then call this command. In fact, you can add a lot more. Let's check if this is working for us. Once again, build. Yes, excellent. In fact, it managed to quickly delete everything in the background and recreate it. That's what we wanted. And also, we need to add Prettier here, similar to what we have in the web app. But for this, we need to install it here too. And yes, Prettier, so I made a mistake. I changed the package.json, then installed the package. If I save now, see, it's telling me there's a conflict. All right, let's resolve it. There's no way. Close it. Open it again. Run the command. And run Prettier. Make sure it works. Let's make a mistake in index.js. We'll just put a semicolon. Save without formatting. And pnpm Prettier works. Great. So, what else will we do in this lesson? I suggest locking the Node.js version so that all developers always use it. You should already have NVM installed, which you use to select the version. And with the nvm list command, you can see which one is currently active. For some reason, I have 18 selected now, but I want it to be 20. For that, I'll go ahead and do nvm use 20. Now I'm using version 23.1. Let's recheck the package installations. Are they not changing? Good, they aren't changing. Let's add a file named nvm-rc, and you can add it directly to the root. nvm-rc. And here you just need to specify your node version. Here we specify this one, and we'll all agree that it's the one to be used. How will it work? The developer needs to enter this project. Let's say he was using version 18 before this. You enter this project and type nvm list. We see that my currently selected version is 18. If I just write nvm use without specifying the version, it will take the one indicated in the nearest nvm-rc file. nvm use. Everything is automatically switched to the required version. Great. Version locked. That's also good. Now I hope we haven't forgotten anything. Didn't forget anything. Excellent. In the next lesson, we'll expand our back-end application, make it much more realistic. That's all for this lesson. Thank you.